Guys, welcome. Yeah, so in this video I'm going to show you how to use the graph option to find minimums and maximums of functions. That is the minimum value and the maximum value of a function, and then points of intersection between two graphs, and then also how to find zeros. I've already showed you in the second video how to find zeros, but this will be like another way to find zeros. Yeah, all right, cool. So let's get started. So first I've typed this quadratic under y1, and remember we go to y equal by hitting diamond and then F1, right? So let me go back home and then hit diamond and then F1, and you get y equals y1 through as much as you want, and then under y1, so the first function, and for now the only function, I've typed this quadratic, which I already know has a vertex at 1 comma -9 and faces up. So I already know that the minimum y value or the minimum value period of the function is -9, and that minimum value is attained at the x value 1. Yeah, okay, so I know that about the this quadratic, and I also know that this quadratic has solutions -2 and 4, right? You can factor this quadratic and see that, right? Because it factors is x minus 4 times x plus 2, and so the two roots or zeros should be -2 and 4. So we'll check that. But yeah, so you type it, and then you type it here under y equals, and then you go to diamond and then F3 for the graph option, and here you'll have a nice beautiful graph displayed, and my standard window -10 to 10 along y and x. And so you find all these things that I just mentioned under F5 right here. So once you're at graph through diamond F3, you hit F5 to select drop down options from here, and you see that I've got functions value here, and then I've got zeros, minimum, maximum, and point of intersection. And what I said I'll cover are zeros, minimums, and if I do minimums, then you can figure out how to do maximums for functions that do have maximums. Notice our function here does not have a maximum, so I can use this example anyway. But yeah, like, and then I'm gonna show you intersection, and we'll wrap up this video. Yeah, all right, cool. So let's start with zeros. So I select zeros, and then it asks me for a lower bound. What that means is that I need to be to the left of my supposed zero, and by left I mean like I need to have x coordinate to the left of that zero. And since you have a visual of where the zero is, you should just scroll to the left of the zero and then hit enter, and that will be a good lower bound. And then you scroll and then be to the right of that zero, doesn't matter where, and you hit enter for upper bound. And then now it'll tell you, yes, -2 for x coordinate, and then 0 for y, and it better be 0 for y, right? Okay, cool. And there it is. And we can find this other one in exactly the same way. F5 and then 0, and this time lower bound. If I so chose, I can choose the lower bound there. I'm to the left of this 0, right? And then I gotta scroll until I'm to the right of that 0. It's a lot of scrolling, but yeah, here I am, and then now there, and there, and I proved the point that you're where you are, as long as you're to the left, doesn't really matter. Yeah, okay, so there it is. 4, yeah, and that's that. And so let's go to F5 and do other things, and this time let's find the minimum value. So minimum value also comes with this lower bound, upper bound question, and so this time what you have to be is, like, since you have the graph, be to the left of the minimum value. Anywhere to the left will do, and then be to the right for an upper bound, right? And then hit enter, and you're good. Yeah, and there it is. X coordinate 1, y coordinate -9. Isn't that cool? All right, and then F5, and finally point of intersection. Well, I can't quite choose this yet until I go to y equals and add a second equation. And for a second equation, or a second function, how about the line 2x minus 1, the line given by y equals 2x minus 1, and this is our second function, so we had to type it under y2. But yeah, you should know this if you've watched my previous videos. But yeah, like, this is good enough. Now go to diamond and then F3 to go back to the graph. This time we need to add that line right there. And maybe my window I need to change along the Y so that we can see the sky a little bit clearer. So yeah, so let's go to window, and that's an F2, so diamond F2, and we just need to change the Y, right? And we don't need the negative parts of Y as much, so I'll just go from -5 and then to, like, let's say 15. Yeah, that'll do us good. Go back to the graph, and yeah, we can't see how low it goes, but yeah, we should see the point of intersection. Yeah, there's that. Now I did this one injustice. Geez. Okay, so how about, my bad, y'all. So it's okay. Right? Okay. I just heard you say it's okay. -10, and then, yeah, let's count by 2s along the Y. How about that? But we still go up, so this should be good. There it is. Okay, this is a much better picture. Now what we want to do is find that point of intersection and this point of intersection. Perhaps it will suffice if I just do one of them. So let's do the one on the left, right? Okay, so what we do is go to F5 and then this time choose intersection. Yeah, and it says first curve, and it already highlights one of them, so just hit enter, and then it says second curve, and then yeah, we'll highlight the second, hit enter. And so, you know, maybe you have more than one point of intersection, as is the case here. So for each one you got to do this, which is have a lower bound after you've chosen first curve and second curve, and those are automatic choices pretty much, and you just have to hit enter, and then you come here and pick a lower bound, be to the left of the point of intersection, put through this, so you got it, and then upper bound be to the right, hit enter. There's that point of intersection, X and Y coordinate, and you'd similarly do that other. So this might be a good time to end this video. Yeah? All right, cool. Keep watching. A lot more to come.